our purposes, a blockchain, let's just start there. What is a blockchain? That's kind of what we're all here to talk about. So quick yes or no poll. You know what a blockchain is. You've already heard of that. You've already done some research on that. This is not news to you. Or vote no. You've never heard of this before. What is a blockchain? You're hoping to learn. All right, so 90% of people say, yes, I've got some coins, or I've done some research, or I've been paying attention. And a couple of people said, no, I've never heard of a blockchain. So blockchain is a special type of database. It's very exciting. It has sequential blocks, which is why it's called a blockchain. And it's basically just a database like anything else, but the way that it stores information is sequential. So one thing after the other in the order that it comes in. And there will be a lot of buzzwords and a lot of excitement around blockchain and whatever in the news and articles you might read. But at the end of the day, it's really just a database. It just stores data, and it's pretty boring. So what's more exciting is Ethereum. And Ethereum is a special project that I really like. It has a lot going for it. And Ethereum uses a blockchain. It has its own blockchain, which is a database. And the main twist is that you can write code that goes inside of the Ethereum blockchain that anybody can run. And that's really powerful because it creates this virtual world computer. So we are going to write some code for the Ethereum blockchain. So I'll say this again, but at any time, if you have any questions about anything I've said, just go ahead and click the raise hand button and ask your questions, and I'll try to get through everything. So next slide is Solidity. What is Solidity? Well, that's the reason you're all here today, right? So Solidity is a programming language. You might have heard of Java, JavaScript, Python, programming languages, right? Things that developers and programmers use to create apps and places and things online and stuff, just really anything. So what is Solidity? Solidity is a programming language for Ethereum. And when we said in our last slide that Ethereum is a database for code, that code is written in Solidity. So that's the language that we're going to learn through today. So quick poll, yes or no, who has heard of smart contracts before? Who's heard the word smart contract? Or you know what that is, or somebody said it. Okay, so a little bit similar to who's heard of blockchain. 90% of people saying, yes, I've heard smart contract. Well, smart contract is a really, really great buzzword. Possibly, in my opinion, one of the best branding buzzwords that developers have come up with in a long time. And what a smart contract is, it's just a block of code. It's a class. If you're familiar with other programming languages like Java or C, they use class files. A smart contract is a class, and really, if this is your first day intro to Solidity, all you need to know is a smart contract is a place where we write some code and where we can execute it, and that's it. All right, so Solidity, our programming language, has different types of variables and types that we're going to use. And at the end of the day, every programming language is just manipulating data, changing types, and setting numbers. So a couple things, I don't expect everybody to understand everything here right away, but this is going to be sort of a guide to the syntax of Solidity language. So visibility, in most programming languages, you have public or private. In Solidity, we also have internal and external because we want to keep track of who is allowed to run certain code in certain places, and should we have code that only our contract is allowed to execute but everybody can see, And so that's just something else to think about when you're programming Solidity. We have these common primitive types, which is going to be the basis of any kind of coding that you do. So first we have bool. So bool stands for Boolean, and it can either be a true or a false. So when we're writing code, we can create things that are either true or false and keep track of that. Next we have uint, which is an unsigned integer, the U standing for unsigned, which is a little bit different than any other programming language that I've worked with, because we can't use decimals and we can't use negative numbers. So there are various sizes of uint. So uint 8 is a number that can go between 0 and 2 to the 8th. A uint 256 is a number that can go from 0 to 2 to the power of 256, which is a very, very large number. So it's a little bit different than most other programming languages that you'll learn, because we're not using decimals. And yes, there will be a recording at the end of the session. We're not using decimals, and we're not using negative numbers. So we have to be a little bit sneaky if we want to use more different types of numbers like that. But the basis and what we'll focus on today is that we have Booleans, true or false, we have integers where we can keep track of numbers, and we have a couple other types here. So one that's very specific to Solidity is the address type. So let's do another quick poll. Yes or no, you have a public Ethereum address. So you've downloaded MetaMask and you know what a public address is. Okay, similar split. So we've got about 90% of people saying yes, or a little bit less even. Okay, so some people don't have an address, but an address is going to be a long list of numbers and letters that is kind of like your house address, in that it's a place that people can find you, and it's specific to a person or somebody we want to keep track of. So when we have our Ethereum address, that's a place that we can send ETH, the currency that runs the Ethereum blockchain, or we can assign tokens, or we can send things, or we can give permission to people to do things. An address is how we keep track of who's who, who's in charge, who has how much wealth in our systems, and anything related to that. So we will get into that a little bit more later. But Ethereum addresses are unique. Nobody can have the same one. There's no two people that can have the same address. And they're a very, very secure way of keeping track of people and things. So we have strings, which is what it kind of sounds like, a string of letters. So it could be foo, it could be words, it could be a name, anything. And yeah, those are basically the basic primitives to writing code in Solidity. So if you've done some other programming, that will make a lot more sense. And if you haven't, we're going to get into some examples in a minute after we get into some data structures. So here's a quick question for the class. If we can use really small numbers like uint 8, which goes from 0 to 2 to the 8th, and we can use really big numbers like 2 to the 256, what situation do you think we would want to use a uint 8 with a small number? So go ahead and comment that. Less gas fee for your contract. Possibly. Possibly. Not necessarily what I would be thinking of. Anybody else have an answer? Do you want to comment in the chat? Why would you want to use a smaller number? Less memory. Yeah, it takes up less space. That's right. Quantity of coins. Yeah. So maybe we want to have NFTs, yeah, sure. Maybe we want to have something that is only allowed to go up to a certain number. It's only allowed to go up to, what's 2 to the 8th? 256, 0 to 256. Good, thank you. So possibly we want to keep track of some number of coins, but we want to have a maximum number that are allowed. So we can say, all right, so let's keep track of the total in a number that only goes up to 256. Or maybe we want to keep track of the number of people in our club, but we only want to allow a maximum number of people to join. This is a really good way to do that, and without having to write any extra code, we get these really cool numbers that we can cap to a certain size, which can be very useful. Cool, so those are kind of the primitive types. I spent a lot of time on this slide, so we're going to keep moving on. Next we have data structures, and we're going to get into some examples after this slide, so hopefully things will start making more sense, but we have to cover all the terms first. So we have arrays, which, let's do another poll. Yes or no? Yes, I have created an array in some other programming language before. I know what an array is. Okay, about 20% of people, 15% of people have not created an array. So an array is the most simple of the more complex data structures. So an array is a list of items starting at 0 and going on for some number of time. So we have a list of items, and each item in the array has an index, which is the order of it. So if you had blocks and you were stacking blocks on top of each other, and each block had a letter, you know, the little ABC blocks that babies play with, that could be an example of an array. So pretty simple. Every programming language has to have arrays, and it's very very basic. So we will get kind of into some more examples of that. Specific to Solidity, arrays are dynamic. So you can say, I want my array to only be of a certain length, and it can only be that length. And when I say length, I mean the number of items that it can hold. Or it can be dynamic in a sense that you can keep adding items to the end of the list and keep adding more and more data. But arrays are not always the best way to keep track of things. Sometimes we want to create our own data structure. So in Solidity, we can create our own structs, data structures. And we can use the keyword struct and then create a person, for example. We can create the name, for an example, we can use the keyword struct, the name of the object we want to create, and then use curly braces and some of the other types of data structures that we already know, like uint8 and string, to create structures that suit our needs. So if I wanted to create a person object, maybe that person has an age, and maybe that person has a name, and we could create the structure of person that has that data associated with it. So we can really be completely arbitrary and create a structure for anything that we want using these types that we've already talked about. Great. So another thing is in Solidity we have mappings, which is its own way of calling a hash table. So here's a little bit more advanced poll. Yes or no? Have you heard of a hash table before? Have you heard of a hash table? Okay, that's about 50-50 on hash tables. I wouldn't expect most people to know what a hash table is. And it definitely doesn't have anything to do with weed. But it is a data structure that we can use to very fast, very quickly look up objects in the data structure, and that we can very quickly put things into it. So There are lots of hash tables going on in the internet behind you that you don't even know about, probably for the best. Most programmers, I think, don't even have to worry about hash tables, but when we're programming in Solidity, hash tables are very useful because we can create mappings. So this is a little bit complex. We'll get into a specific example next, but we start with a mapping, which is a keyword, mapping, and then in our parentheses we say, what do we want to start with and what do we want to go to? So we create an address and then an equals and greater than sign, which really is just an arrow. It's not the syntax I would have chosen for that, but in this example, we're mapping an address to a uint. So we put in an address, and it gives us an integer. So how could that be helpful? What kind of thing could you do if you had this data structure that you could create a list of addresses, and for that address, it will give you an integer? So somebody comment here. What do you think? What do you think that could be really useful for? A ledger balance. Yeah. That's right. Yeah, pretty much. Ledger balance. So keeping account balances. Yeah. Right. So in our example here, we have the word balances, which is the name of our mapping. And we have an address that points to a uint. So every time we say, hey, let's look up an address, it gives us a uint, and that could be the balance of somebody's account in our bank. Or it could be, we look up somebody's address in the phone book, and it gives us their phone number. Or we make a mapping of strings, like in the little diagram on the right, mapping of string, which is somebody's name, and we put it and connect it to some number, and that's their phone number or something like that. So it helps us keep track of our data a little bit cleaner and a little bit faster than an array. But it looks very similar. So the last thing is a num type. We're not going to really get into that today, but if you wanted to create your own version of the uint or your own thing, your own string or something, instead of using a Boolean for true and false, you could create in a num type, open or closed. So if you want to create your own data structures, that's another way that you can do it, but we're not going to get into that today. So yeah, arrays, structs, and mappings are very important. That's the summary of this side. Let's move on. So here's an array. Here's an array. An array is a list. In this example, we have an array of money. At position 0 in our list, we set the value 5. At position 1, we set the value 1,000. So money array, position 0 equals 5. Money array, position 1 equals 1,000. And we have this little graph, or box underneath rather, where we're saying the index of this array, so the order 0, 1, and the values. So that's pretty cool, because we could keep track of who in our list here has how much balance on our ledger, or if we want to create a bank, which index has how much money. So this could be really helpful, but we don't really know who number 0 is. Which person is number 0 in our list? Which person is number 1 in our list? So we could improve that a little bit by saying, hey, let's pretend the person who is at position 0 is Joseph, that's me, and the person at position 1 is Abby, and this is how much their balance is. This is how much each person has. But this doesn't really work, because it's just an array. We have to keep track of it by index. So now that's a little challenging. to be able to associate Joseph with 0 and Abby as 1. But you can see that this would be a really simple way to keep track of if we wanted to create a token, if we wanted to create our own ledger, our own way of keeping track of how much of some certain value that somebody has. So this is really important. This is a really fundamental thing to understand before we get any deeper. So are there any questions on sort of how this array looks or the data structure? And we can spend one more minute here. All right, let's do a quick poll. Who's happy? Are you happy? 100% yes. Excellent. All right, so that means everybody's following along. Great. Okay, we're going to move on then. So perhaps we don't want to have everybody's name because 2 people could have the same name, and that could be confusing for our list. So what if instead of using a name, we used an address? And this sort of example down here is this row that we've added, 0x, which is just an identifier, a way to be able to identify where an address is in a string. ABC 1, 2, 3, DEF 4, 5, 6. And that's sort of the beginning of what an address on Ethereum might look like. It's just kind of a gobbledygook of letters and numbers, but it's very unique. So if everybody, instead of having a name that somebody else could have, has a very completely unique address, then that could be very helpful. You'll notice the value is 0, even though we haven't set it as anything. Because if we have a list in Solidity of U integers, if we have a mapping of anything to a U integer, the default value will always be 0. So if we haven't set anything, by default, it's 0. So we have these names, and we're saying Joseph has 5, Abby has 1,000, and this address, which we haven't interacted yet, by default has 0. So our issue with the array, oh, that's not where I wanted that to go. All right. The issue with the array is, how can we possibly keep track of every single possible address that exists? Because there's millions and millions and millions. So we are going to need a special function that can, just for any arbitrary address, return how much of that value is. So we want everyone who hasn't interacted with our system that we're building, our app that we're making, to have 0. So mappings can do that. So a couple blockchain-y things, and then we're going to, isn't an index of an array an immutable property? Yes, this is just sort of an example of, that is a great question, Will. Thank you for asking it. This is an example. This is not actual code. This is sort of an example to demonstrate what is an array and how we should be thinking about that. So really, in your head, we can pretend that we're using this. We're using money of 0 is an integer, so we're getting every item by its index, and we're just saying, oh, by the way, 0 happens to be Joseph and 1 happens to be Abby. I hope that answers your question. So anybody else, if you have any other questions, I'm keeping an eye on the chat, so please ask and raise your hand or give me claps if in reactions if you like what I said. And all good. Okay, cool. We'll keep going. So this is the last thing that we are going to talk about, and then we're going to write some code that's real examples. Most people said that they've seen code in some other languages or other things. These are just a couple variables that are always accessible. You can think of them as global variables, but if you're writing code in Solidity, because it exists inside of the Ethereum blockchain, you always have access to these 4 things. And a few other, but these are the ones that I'm going to focus on right now. So message.sender is the address of the person calling a function. So it's always the person, every time some code gets executed, somebody is executing that code, somebody is making that call, and we can always check who that is for every situation using message.sender. We can always see the amount of ETH, which is, again, the default, the currency that runs the Ethereum blockchain. We can always see how much ETH was sent in a function call in running my code using message.value. And we can always use the block and the block number, which is the order of blocks in the database, and the timestamp. We can always access those. Sometimes people try to use the timestamp for randomness, but that's not a good idea because it's very predictable, and the person mining the blocks can influence it. So we can't use those for random numbers ever. Oh, I answered my own question. Oops. So why can't we use the block.timestamp to get random numbers? Because this is not a regular database. This is one that everybody has access to. And because of that, anybody will be able to influence our random numbers. So we have to do a little bit better. And if that doesn't make sense to you, that's okay. It's not really important. The most important thing here is to remember that every time a function gets called or something happens in our code, we always know the message.sender and the message.value. We always know who and how much value is associated with that code executing. All right. Functions, this is just a syntax thing. Can we rely on timestamp for tracking real-world time? Good question. Thank you for that, Roy. For example, to check if a few hours have passed. Yes. So the timestamp is going to be part of Unix. It's going to be a Unix timestamp. It's an integer type, and you can always check to see. You can store that timestamp somewhere and say, this is the time that this happened, and then wait a few hours and say, all right, make sure this much time has passed before something else happens. So you can always do that. So yes, the timestamps are very reliable, and they happen you get a new one every 15 seconds or so, but not exactly randomly. Cool. Great question. So functions. If you've done any sort of coding before, you've probably seen a function. This is just a syntax slide. And okay, we have another question. Gasper, excuse me. Does Solidity have time series similar to, I assume you're asking about Viper? Yeah, similar to Viper. Viper is another programming language that we're not here to talk about today. And I don't know the answer to that question because I don't program in Viper, I program in Solidity. I would assume something similar exists, but I will get back to you afterwards. So we will not get into that right now. So function, when we want to create a block of code that somebody can run inside of our smart contract, we create a function. So a function could be add, and it could take in 2 numbers, and it could add them together and give us the result. And the benefit of using a function is that it breaks down our code into smaller digestible parts. So we want to be able to use the add function a lot of times, and we don't want it to we don't want to have to rewrite the same code over and over. So we can create a function and use that in different places and create really easy ways that people can interact with our smart contracts, with our Solidity code. So when we want to create a function, first we use the function keyword. then in parentheses, we say, okay, what are the parameters? What are the things that I want to input into my function? So in our example, if we wanted to create an adding function, then we would say, all right, give me the two numbers that you want me to add as our parameters. Next, we have some choices to decide if our function is internal, external, public, or private. For the most part, we're going to just use public and make it accessible and easier to use for everybody. And then we have these other options when we make our function called pure, constant, view, and payable. So these are specific to Solidity. Most other programming languages will stop at public or private when giving you options of what kind of functions to create. And the benefits of this is that it's really explicit because this is, a financial programming language. There's a lot of money involved in blockchains, and we want to be very, very clear about everything that we're doing. So if we're saying our function is pure, that means it does not edit the state of the contract at all. So if we have any data saved there, if it's pure, we are not editing that at all. If it's constant or view or pure, we're not even reading the state. If it's constant or view, we're not editing the state. If it's payable, then this is a function that can intake ETH, that people can send value, and this is a function that can run when somebody sends us value. So these are important things to keep track of, and it helps us be incredibly explicit and clear about what every function does that we're writing. So those are some other keywords to keep in mind. And a question is, when would you want a function that cannot edit the state? So why would I want a function that cannot save any data to my smart contract? Does somebody want to answer that in the chat really fast? So when would I want a function to not be able to edit any of the data in my contract? What situation would I ask? Would I be explicit and say this function is not allowed to do that? Let's see, any answers? Internal admin, or you just want to calculate something without side effects. Yeah, those are both great answers. So some internal admin stuff might be, I just want to return what some data is and give somebody a getter. A getter, is a programming term, which is a function that gets some data from my contract, but is not allowed to edit it. That's only allowed to tell people what some data is. And because we're being really clear about what our function does, we can't even accidentally create something that is supposed to just return data that edits the data. So it's even a really good security thing to save us from ourselves, from making our own mistakes. And the other, Roy said, you might want that you just want to calculate something without any side effects. Yeah, that's a great way to put that. So we just want to add two numbers. We don't want to edit any of our state or override anything by accident. So we can create a function that's pure. Cool. And then the last thing when we create a function is the return, which in our add example, returns the result. Cool. Let's move on. So we're a little bit behind schedule. We're going a little bit slower today, probably because this is the first time I've done this online. But we're going to write some code next. So I encourage everybody to go to this address, remix.ethereum.org. And I just commented that in the chat. And what Remix is that it's a very simple online editor where you can write code and deploy it to the Ethereum blockchain. You can also just do this in a text file or any kind of document that you'd like on your computer. But we're going to write some code together. So it's helpful to do it in Remix, in my opinion. Yeah, so in our code example today, we're going to create our own token. We're going to, from scratch, create the most simple implementation that we can of a token on the Ethereum blockchain. And our example from before, which is just a list of every person that has interacted and how much value that person has. That's it. That's what a token is on Ethereum. And the way the blockchain works is it makes it very secure. So if we can create a cool implementation of this in Solidity, we will have created our own Joseph token, or whatever your name is, or whatever you want to call it. So the first thing that we're going to write, to start a new file, just start a completely empty file. We're going to call it mytoken.sol, or whatever you'd like. You can call it Joseph token, or Blackbeard fun token, or Roy token, anybody else, however you want. .sol is the extension for Solidity files. So just SOL, make sure that it ends in that. And the first line that we're going to write at the top is pragma solidity caret 0.7.0 semicolon. And let's break this string down a little bit. Pragma tells us what version of Solidity we want this code to be. Solidity, this is the compiler that we want to use to compile our code. And the caret and the version number tells us what version of Solidity. 7.0 was recently released, so that's what I'm going to use. And there are lots of other versions, but this is they're mostly the same, not too many breaking changes, and we're going to focus on this one for today. So does everybody have this written down somewhere? Pragma Solidity 0.7. Everybody have that either on Remix or written down somewhere? Yes, cool. All right. So the next thing, when we write Solidity, we write inside a contract. So we're going to use the contract keyword. Note that it's lowercase. And we're going to name my token. Good developer practice is to have the name of your contract be capitalized. So I'm going to say contract, it's called my token, and we're going to open some curly braces, and all the code inside the curly braces is code that belongs to our smart contract. So we have started our contract. So if you've gotten this far, congratulations, you're a smart contract developer. Very proud of you. All right, let's keep going. So if we want to create a comment that does not get compiled and we want to just write a note to ourselves, we can start a line with /. So that's just a syntax thing to be aware of. So next, remember uints from before? Well, we can define anything at the top of our smart contract like this, just here, and say uint 8, which is an unsigned integer. We can give it a name, like my number. So that's the name of our variable. And we set it equal to something. So all of these variables that we create at the top are sort of state variables. They're what we're saving as data in our contract. And it might be helpful to keep track of who the owner of this contract is. That's us. So who is that person going to be? So quick question, put the answer in your chat if you remember. Who is the person who's going to be the owner, and how are we going to figure out what that person's address is? So who remembers that? I'll give it message.sender. That's right. Way to keep track, guys. That's awesome. So message.sender is going to be the first person to call the contract. So we can say we want the owner. Well, who's that going to be? Let's find a way to set it to message.sender. So what else do we need in our our we'll do that. We'll do the message.sender in a moment. But what else do we need to keep track of in our token? The only other thing is who owns it and a list of the addresses, keeping track of who owns how much. So generally that's called the balances, and we're going to create a mapping type variable that maps every address to a U integer. And I created a 256 integer, but you can create whatever size you'd like. We want the balances to be public, and you'll notice we end every line with a semicolon. So if you've done any programming in Java or C or anything like that, that should look pretty familiar. So this should be pretty much it for all the variables that we need to define at the beginning of our token contract. So next we need to create a constructor. Let's do a quick poll, yes or no. Who knows what a constructor is? I know what a constructor is. Okay, about 60-40 on what a constructor is. A constructor is very popular, very common in pretty much every programming language. You have a way to initialize every object. So let's create a constructor of my token. So I created function myTokenPublic, and what that is going to do is it's going to initialize the contract. So this is code that will run. Everything inside of a constructor is what runs the first time that that contract is deployed, the first time that it's moved onto the Ethereum blockchain. So when we have our address owner and we want to initialize that when the contract is created, we can do that, and anything else that we want to be set up the moment that we deploy our contract inside of the constructor. So remember the person struct from before? It had an age and it had a name. So at some point, if we want to create a person object, we'll need to initialize that with a person constructor and say, give a person this age, give a person that name. So every object can be initialized. Our contract is an object, so we initialize it with a constructor. And we have a question from Gunnar. Is the uint where you define the amount of decimals the token can be broken down to, or is that later? We're not actually going to do that decimal stuff. I can talk about that later. But basically, the way that we implement decimals inside of Solidity is we pretend that everything is actually a number times 10 to the power of some other number. So if we have, in other contracts, you might see like decimals equals 18. So we pretend that every number is actually 10 is actually the number divided by 10 to the 18th. And so you can do floating point math, where, you know, if you've done work with really big numbers before, you've seen, you know, oh, it's 3.5 times 10 to the 5th, but actually, that, you know, that's 35,000 instead. But we don't need to keep track of that today. I hope that answers your question, Gunnar. But we're just going to use regular U integers because we're keeping it simple, and this is an intro workshop. So we've got our token contract, we know what version of Solidity we're using, and we've created a constructor. Also in Solidity, in newer versions, you can just use constructor instead of function myToken. So I've changed that here, and just for simplicity, I'm using the keyword constructor. And like you guys said before, the owner is going to be the message.sender of the first thing. So owner equals message.sender. So when this constructor, when this is called, which happens when the contract is initiated, then the owner will become the message.sender. What else do we need to do here? What else should be initialized at the time that our contract starts? How many we minted? That's right, yeah. So how would we do that? we want to initialize how many tokens are going to be total, or at least to start with. So we have a mapping of public addresses for the balances. So what do we need to do to decide how many are mapped? How many tokens there are total? We'll give that just another second because we need to keep moving here. How many are minted? I don't see any answers coming up, so I'm going to move on and just show you. Sometimes that's the best we can do. So we want to set some initial amount. Then we can say balances. We can use open brackets, the same as an array, to access any mapping. And remember that owner is of type address. So that means that we can do balances of the owner equals 1,000. And that will mint 1,000 of my token and put it into the mapping. So as this constructor runs, what's the result here? Well, we have the owner equals the message.sender, that's me, and then the balance of the owner equals 1,000. What's the balance of every other person? 0, right, exactly. The balance of everybody else is 0 because that's the default. Nobody else has interacted with it. So if you've gotten this far, you've just created a token and you gave yourself some number of them. It doesn't have to be 1,000, it can be any number. So congrats, you're rich in my tokens. You have all of them, good job. So what else do we need in our token contract? There's basic functionality. There's only one other thing that we really need to create a useful token that people can actually use. So currently all of the tokens belong to the owner. So what other function is missing here that we need to be able to use our token? A send function. Yeah, transfer, even better. So we need a way to be able to send that to other people. So currently the owner has all the tokens, and we're going to need a way for other people to get some of those. So I just made a ... to scroll down. So we created a new function. We use the function keyword. We are calling it transfer. You can call it send if you'd like, or move tokens, or whatever else you'd like. So we create our new function, and this function, unlike the last one, is going to have some parameters. It's going to have some things inside of those parentheses that we want to input. So what are the two things that we need to know to be able to send some tokens? Well, we need to know how many, and we need to know where they're going. So we're going to say how many is going to be the amount, and that is going to be of type uint. And you'll notice that there's no number next to my uint. So by default, if I haven't specified, then in Solidity, any uint that is unspecified is uint 256. So send some amount, and then comma for our next, to get our next item in the parameter. So we're going to say address recipient. So now we can access in our function the amount of tokens that we want to send and the recipient who's going to get them. And let's make this function public because we want everybody to be able to have the power to send tokens on our platform. So what are the two things that we need to do when we send a token? Currently, 1,000 tokens belong to the owner. So if I wanted to send a token to Will, who just commented, what are the two things that I'm going to need to do so that Will can have a token and I can send it from my account? So what are the two things? Just comment one of them if you know. So we have his address. We have his address. Will's address, if he's the one I want to send it to, is going to be the recipient. So the two things we need to do, that's right, is deduct from the sender and send to the recipient and add to the recipient. So withdraw and deposit. So let's do that. Let's do that first. And we'll get to what you said in a moment, Roy. So we always know who is sending this transaction. We always know. And we know that from the message.sender. So whoever called the transfer function is the message.sender. And that's an address. So that means that we can use our balances structure and say balances of the sender of this function subtract the amount. And it's always good good security, good choice to subtract first, because that way there's nothing can happen in between, and that's just good, just a good idea. Probably will be fine to do it in reverse, but it's just a good idea to subtract things first. And then the other thing that you said was add to the recipient. So who is the recipient? It's address recipient. We have that as one of our parameters, and we can access that anywhere in our function by just typing recipient. So we look up the balance of the recipient, and we do plus equals amount. So you'll notice the minus equals and the plus equals is just a shortcut of the amount equals the balance equals balance minus amount, or balance of recipient equals balance of recipient plus amount. So we want to subtract from something, we can just use minus equals and plus equals. Yes. So we've done those two things. We've deducted from the sender and we've sent to the recipient. Hooray, we did it, right? We just created a function, a token, and we gave some to ourselves, and now we have a way to send it to our friends. So why isn't this quite enough? What is the problem with this? Yeah, Steve got it. Anybody else have another idea? Anything else you want to add to that? We'll give it a few seconds here. Gas. Not quite. That's okay though. So recipient address is valid. All addresses are valid because we don't have a list of all the addresses. We have a mapping. We have this mapping that any address can go into. So any address is going to be valid if it works as the recipient address, if it works as a type of address. So recipient is type address, so it will always be valid. So we definitely want to make sure when you're using functions like this that you're sending it to the right person, because there's not going to be any validation that you've sent it to the right person in the functions. Transmit to ETH blockchain. Everything that runs in this function is running on the Ethereum blockchain. So we don't need to do anything special for that yet. So we got it we got it before. I hope that answers your question, Will. But we got Steve totally nailed it. We need to check that the message.sender has enough to give. So if I have $0 in my account, what happens if I try to call this function and I send $1,000 to my friend? It will deduct 1,000 from my account, and then it will give 1,000 to my friend. But I didn't have any in my account if I had 0. So we need to do something about that. Let's learn about require. Require is another keyword that we can use at any time in Solidity. And require allows us to throw an error if the thing inside of the require function here, inside of our parentheses, is false. So we require that what's in here is true. So you can always set that as a Boolean and say require that contract is on equals true, or anything like that. So what do we need to require here to make sure that the person sending has enough to give? What goes inside of this to make that true? Balances of message.sender is greater than or equal to the amount. Boom, both of you nailed it. Awesome. So let's add that to our code here. So we require, when you call this function, that the balance of the person sending the function is at least as great as the amount that you're trying to send. So yeah, so what happens if I have not enough of amount? Solidity doesn't have negative numbers. What if we subtract a bigger number from a smaller number? That's a great question. We're going to tackle that next slide. That was kind of the question that I'm asking here. This function can be attacked in certain ways. And we're going to get into that next. But let's just walk through this syntax really fast here. We require balances of message.sender. The greater than sign and the equal to sign will return a true or a false based on what is greater than or equal to. So if that is true, then we're allowed to keep going. And if that's false, then everything stops and no more code executes and anything that's happened reverts. And this function will not go through and will not happen on the blockchain. So we can use these requires all over the place to make sure people are playing by the rules. So why isn't this quite enough? This function can be attacked. There's no negative numbers. So what happens? What can happen here? If I had a uint, say, that only went from 0 to 16, what is susceptible here? What could happen here? Overflow. Yes. I don't know how to say your name because I don't know the Russian alphabet or wherever you're from. I'm very sorry. But overflow, this person in chat nailed it. So if we have the number 15 and our uint only goes from 0 to 15 because it's, what's that, 2 to the 4, I think, right? Yeah, 2 to the 4. So we have a uint 4, and it only goes from 0 to 15, 16 numbers. What happens if a person has 15 and we add 1? It's going to do an overflow, what's known as an overflow, because it's going to tick up 0, 1, 2, 3, up to 15. You add 1 more to it, and it starts over. It goes back to the beginning. So if you have 15 and you add 1, and you're only allowed to go up to 15, it goes to 0. So right now, even if the person has enough money to send, it's possible that they could overflow the amount. Evelyn in English. Okay. Awesome. So what do we do here to prevent an overflow? What can we do? Another require. Yes, add more requires. And what are we going to do to require? This one's a little bit tricky, so I'm just going to move on and give it to you. We're going to require, I added 2 here. Only 1 is really necessary, but I've added 2. The first one requires that when we subtract the amount from the sender's balance, that they have less than when they started. And when we add the amount to the balance of the recipient, that they have more than they started with. So it's impossible here for anybody to gain anything extra, to gain any amount by sending, and impossible for you to lose any amount by being sent. So the first require, make sure the message.sender has enough in their account. The last one, make sure that they will always have less or equal to whenever they send. And the third require, make sure that whoever is the recipient can never lose money by being sent money. So this will stop all overflows, all underflows, which won't really happen in this scenario, but safety first. And nobody can send anything that they don't have. And that's it. That's all the code that we need to create a simple function. So Roy has a question. Do we always have to do these checks for basic math? Isn't there a library that does that for you? Yes, that's a great question. It's called Safe Math. It was created by OpenZeppelin. And to do that, you'll need to import and use libraries. So that's a little bit more advanced than we want to get into today. So yes, you need to be really explicit about your numbers and what's possible when you're programming in Solidity, because of how the number system works. And it is really tricky, but it has, when you learn more about the security and you get into it, having a number system like this actually has a lot of benefits that might not be super clear right now, but you're just going to have to trust me. So we've created our transfer function, we've created an initialization function, and now you can launch your very own token. So on Remix, you can be able to launch it. I'm not going to get into that for today's workshop because time constraints were a little bit over, and I just want to focus on the code today. But now you can deploy this function to the Ethereum blockchain. You can have a token, and you can send it to your friends. So congratulations, give yourself a pat on the back. If you made it this far, then you built your very first, your own token on the Ethereum blockchain. Congrats. So here's some other links to some helpful stuff. A Solidity cheat sheet I find really helpful for remembering all the syntax. There were a lot of keywords that we went over today. Examples on how to do things, and the official Solidity documentation. I guess this link is not perfect because it should be version 0.70, but this slide is a little bit old. And the next place that I recommend everybody go to is chainshot.com, and they have a lot of really interesting tutorials that will walk you through code, and it's a great place to get started. So I'm just going to scroll back to the top. Hopefully everybody still has the link to this slide. If you don't, I can comment it again, but I'm going to just go back to the beginning here and say, hey, join me on DC Blockchain Slack if you would like to talk to me or ask any questions about that. I will always be around there. It's a great place to find me. And yeah, thank you so much for coming to my workshop. I hope that you learned a little bit something today, and I will stay online for a little bit longer if anyone has any other questions about what we've done today. So thank you so much for your feedback. I really appreciate that, Steve and Gunnar and Jada and Timothy. Fantastic. Yeah, I can't do this if people don't show up. So thank you for coming and telling your friends, and we'll do some more of these very soon. Awesome, awesome. So any other questions? Any other questions about the code that we wrote today? Did you miss the final slide? The final slide was of my friend Patrick, who the last time I gave this workshop, we did it in person together. So that was him. And but he's not here today, obviously. So yeah, thank you for coming, everybody. And send me an email if you have questions, or you heard about it from a friend. I'd love to hear more about how you found my workshop link, or what topics that you want to learn next. I'd love to do this weekly or bi-weekly or something, and just answer people's questions and build stuff together. I've really done my best to make sure that it's not all buzzwords, and that we're kind of trying to focus on the utility of learning these kind of things. So yes, a link to the slides. Let me get that for you. Right. Let's see. Copy link. Yeah, I'll drop that right here. Here's a link to the slides. There'll be a recording of this, and follow me on Twitter at CupOJoseph. And for sure, there will be follow-on workshops. I'll definitely keep everybody invited. So thank you. Slides are here. Bye, Roy. Thank you for coming. And yeah, I think if nobody has any other code questions, then I will end this, and I'll put the recording on YouTube and make sure we send that to everybody to share with their friends and things. Give that just another moment. But yeah, please join me on Slack, and see you all next time.